Alright, today we're talking about linear systems of equations. So there are really three types of possible solutions to linear systems. There can be one solution, so that's just what will be a single ordered pair. There can be no solution, that's a possibility. And there can be an infinite number of solutions. So those are the three possible categories, and we'll get into each of those as we move through this unit. So this will be the first video for this unit. So a linear system solution is simply where two lines cross. So if I have a line like this and a line like this, the solution, in this case the single solution, the one solution, is that x comma y, that ordered pair where these two lines cross. If it's no solution, then that would mean that I have two parallel lines with different y-intercepts. So two lines like this would never cross, therefore there would be no solution. And then an infinite number of solutions would be when you have two lines that are the exact same. So if I graph a line and then I graph the other one, for example, and it's right on top of it, then that would be an infinite number of solutions because they share an infinite number of ordered pairs. So those are the three possibilities. Now we're going to be looking at graphing first. We're going to solve these by graphing. So I'm going to slide this over. Solve by graphing today. So when you solve by graphing, all you do is graph the two lines and find where they cross. So we'll start with this one. I'm going to underline this part in red. We'll use red for this one. So we graph it. This is in slope intercept, so this is my y-intercept. You know how to do this, -2. And then I use my slope of -1/3 to get to the next point. So down 1 over 1, 2, 3. Plot another one, down 1 over 1, 2, 3. Plot another one, down 1 over 1, 2, 3. So there are points for that line. We'll plot it in a moment. This line, I'll underline in green, we're going to graph it. So its y-intercept is -4. Slope-intercept form gives me the y-intercept and the slope. So y-intercept -4. Slope is +1/3, so I go up 1 over 3. Up 1 over 1, 2, 3. Notice these share. So I'm going to circle that point. Up 1 over 3, 1, 2, 3. Up 1 over 1, 2, 3. So we plot those two in. And that line there, and this line here, and the ordered pair where they cross is the answer. So I can see they cross at an x value of 3 and a y value of -1, 2, 3. So the solution to this linear system is the ordered pair 3, -3. That is the point that they share, and this actually has one solution. So that was the first over here when we talked about this. That was the first possibility. Alright, now this next example. So we're still solving the solution by graphing. So we'll do this one in red. So its y-intercept is +1. Its slope is +2, so that means up 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And then we'll graph the second line, y equals 2x plus 4, in green. You may already be able to tell what's going to happen here. So we have y equals 2x plus 4, y-intercept is +4, up 2 over 1 because the slope is 2, so up 2 over 1, up 2 over 1, up 2 over 1. Alright, so we plot these in, green one through here, red one through here, and it's not a perfect graph, but that'll work. These two lines have the same slope, so they will never cross, so the answer here is there is no solution. There is no ordered pair that they share. These two lines are parallel, same slopes, two different y-intercepts, 1 and 4. They will never cross, so our answer is there is no solution. Alright, continuing on here. Example 3. So we'll graph this one in red. 2x minus 4. Y-intercept -4. Slope is 2, so up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. I usually plot the points in here first, and then I'll put the line in later. So there's that one. We'll do the second one in green. Y-intercept is 3. Slope is -5, so down 5 over 1. 1, 2, 3, 4, 5 over 1. So there's the point they share right there. Down 1, 2, 3, 4, 5 over 1. So that's enough to plot it in there. Here and here. That's not very good. Let's try that again. So the intersection is at the ordered pair 1, -2. This intersection, the point that they share, is 1, -2. So the solution to this linear system is 1, -2, and we would say there is one solution here. There's only one point that they share. All right, now for example 4, so we're going to solve by graphing still. In order to graph these, we need them in slope-intercept. They are in standard form. So we're going to get this one in slope-intercept form. So I'll do that down here. We'll do that one in red. Put an arrow here. So x minus 3y equals 6. Subtract the x by bringing it over here. So it would be -3y equals -x plus 6. Divide everything by this -3. And finally we have y equals -1 divided by -3 is positive 1/3 x, so slope is 1/3. 6 divided by -3 is a -2. So there that one is in slope-intercept form. We'll do this one now. We need y by itself for slope-intercept form so that we can graph the line easily. It's a good skill to always be able to get y by itself. So move the 2x over, it becomes negative, so 3y equals -2x plus 3. So divide by 3 to get y by itself. So we have y equals -2/3 x plus 1. Okay, at this point you want to start getting an idea of what's going to happen. This slope is -2/3, this slope is 1/3, so I expect one solution. Their slopes are different, so they should cross somewhere. So let's plot this one in red. Y-intercept -2, slope 1/3, so up 1 over 1, 2, 3, up 1 over 3, 1, up 1 over 1, 2, 3, up 1 over 1, 2, 3. Okay, the one in green here, this one. So y-intercept is +1, slope is down 2 over 3. So y-intercept +1, always start there. Down 2 over 1, 2, 3. There's our intersection right there. Down 1, 2 over 1, 2, 3. Down 2 over 1, 2, 3. So plot those in there, and we've already identified our intersection, which is our solution. Alright, so that intersection is our answer, and that is at the ordered pair 3, -1. So one solution here, that solution being 3, -1. When x is 3, y is -1. And that is where they share. That is the ordered pair that is the same for both lines. Alright, so let's go back to example 3, and I'm going to show you how you can check these with your calculator. So example 3, we had the line 2x minus 4, so I'll put that in y1, and then the other line was -5x plus 3, put that in y2. Now I'll graph it in a standard window, so I'm going to do a zoom 6. You could just hit graph, but if your window's not set right, you might not see it. So there was the first line. This is the 2x minus 4 right here, and the line that sloped down is the -5x plus 3. So I can see in my calculator window the solution, the answer is right there, but my calculator will actually give me the answer directly. I can do this, second trace. This gives me a lot of options in here. Option 5 will give me the intersection of two graphs, and that is what the solution to a linear system is. It's the intersection. So option 5 for intersect. The calculator asks you always in the lower left-hand corner what it needs you to tell it. It's asking for the first curve. So it's saying y1, the line 2x minus 4, is that the first curve we want? Yeah, sure, fine. So hit enter. Then it asks you for the second curve. You have to tell it what's the second line, or in this case, that you want it to use. We want it to use this one, y2, -5x plus 3. So just hit enter and tell it yes, use that one. For guess, you can arrow and get closer to the intersection, but you don't have to. On the guess, you can actually just hit enter. And when you do that, it gives you the intersection, 1 comma negative 2. That's the same answer that we got. So the calculator is available to check with. I expect you to graph them by hand and know how to do that, but the calculator can be a check for you.